Hello guys, welcome to a series of classes called Liquid at Rest. And now Liquid at Rest, we're going to deal with some series of classes. Of course, you know how my classes go. So we're going to take everything bit by bit. We'll talk about Upthrust, flotation, density, relative density, measurement of relative density. It's going to be a long class. But for knowledge sake, we call it Upthrust, density, and Archimedes principle. Normally, this topic is called fluid at rest, but students don't know it as fluid at rest. Students know it as what density. So this will be our lesson 1. Are you set? Please calm down. I'm going to show you things in this topic. You are going to understand beyond the surface, and you will go deep. Settle down, take a chill pill. Let's move. Now, before we start, this class is brought to you by the LearnLift app. The LearnLift app covers all manner of examination, be it Jamb, be it Waec, be it GC, be it GC, be it NECO. Talk about your JUPEB. We cover JUPEB classes, we cover preliminary classes, we cover what question. This teaching cover for everything. Physics is physics, and no matter the exam. Do you understand? We also have classes for 100 level. We have classes from SS1 to SS3. For those of you that you have younger ones, you want them to start knowing from the scratch. SS1 to SS3. We also have from GS1 to GS3. So we are working continuously. Everything is in the app. Now take note that if you create a class in the LearnLift, this is how it look like. Let's say you choose Jamb And Waec. This is how your own class will look like. It's different from someone that chose 100 level. Different from someone that chose 200 level. You can see your subject. Let's say you now click on physics and you choose any topic. Let's say you choose thermal physics. You can see we have videos, we have notes, we have passages of the videos. You are going to watch the videos clearly, just the way you are watching me now. Do you understand? About videos in the app is even more clear than what is on YouTube. Do you understand? So, and it has low data consumption. When you download it, you see the size of the videos. Now, you can see that these are the notes. You can see these are in the notes as inside the note has note, and it has past question. All the past questions on that part, for example, if you are learning thermal physics, all the past questions on thermal physics are under that note. So even if you are not playing it in the CBT format, you already have it in the note first. You can see detailedly explain why it is so, and it is arranged based on what you read. Do you understand? We also have past question. We play past question in class. There's past question in note. There's also the topic by topic CBT, which you see there, which contain what past question. Do you understand? Now we also give scholarship information. Many of our students are in different countries, so if you're interested in scholarship, there's major one that comes up every year ending. You want to participate, DM us, chat us up, chat this number, and you get and also belong to our WhatsApp community where we share information, any update, everything you need to know. Do you understand that? Now what is the objective of this class? First, the objective of this class is that we are going to learn everything in fluid at rest. What are the things we are going to learn? Number 1, we'll start the things you need to know. We'll cover what we call your Upthrust. Upthrust is a class on its own, and it has its own past question. That means another class on its own on Upthrust, and you can see. So this is a series. So after Upthrust, we'll talk about what flotation before Archimedes principle. So we'll talk about Upthrust, we'll talk about flotation. Do you understand? I will talk about Archimedes principle. Now we'll talk about your density. We'll not talk about relative density. We'll not talk about measurement of density and relative density. Do you understand? I will now treat their past question. Now this is how it will go. You're going to see it with your eyes as we travel. We'll treat everything about Upthrust. We'll balance it because that's the beginning. We'll now treat the past question. Treat everything about flotation, Archimedes principle. Treat the past question. Treat density, everything about density. Treat the past question. So all of them may be one class on their own, so that you will grab it. Quickly, sit down, let's move. First of all, I'll start by telling you that the word Upthrust means buoyant force. So Upthrust is also called buoyant force. Everybody was also called Upthrust, also called buoyant force. Where does the mindset of Upthrust come from? When you insert an object, a bucket of water inside water, there's a bucket, and that bucket has water. The bucket is heavy. When you put it inside water, you observe that bucket appears to be lighter. But when you remove it, the bucket is heavier. If you put it inside water, it appears to be lighter. That's because of a term known as Upthrust. Now, let's go one after the other. When a heavy object is immersed in fluid, it appears to become lighter. When an heavy object is immersed in fluid, it appears to become lighter. Now, for example, a bucket being drawn out of a well feels lighter while it is underwater. While it is underwater, the bucket feels lighter, but heavier when the bucket is out of the water. Have you seen that? This was explained by a scientist called Archimedes. Look at it. This effect was explained by a scientist called Archimedes, which says that object experienced a force, an upward force, and that upward force is called upthrust. So, constant past question, you will see an object when immersed in fluid becomes lighter because of the upward force exacted on that object. That upward force is called your what? Upthrust. So, why will objects appear lighter? Objects are going to appear lighter because of upward force called upthrust. Upward force called upthrust. Everybody, do you catch what the main message in this first part? That an object appears lighter because of what? Upthrust. Object immersed in fluid appears lighter because of what? Upthrust. Now, the question is now, what is upthrust? Now, let's explain something. Let's explain water, and an object is being immersed in water. That object is going to have weight. Weight acts downward. So this is the weight of that object. You can see it. This is the weight. Now, as you are putting that object in water, you observe that there is a resistant force trying to oppose the water. So you need to put it with force. That force is an upward force. That force is what we call your what? Upthrust. Of course, your rope or your hand is still on that heavy object. So we call that rope or your hand tension. Look at it. I take an object. You carry a bucket of water. That bucket of water is the weight. You put it inside water. Are you seeing that weight is acting downward? Your hand is this rope or your tension you can see on the screen. Why that upward force that is opposing it is called the what? The upthrust. So the upthrust, it is the force from the water. Why this weight is this weight of this object. Why this tension is what balances the weight, because you two, you are holding it and you are holding that bucket. So you are this tension. This weight is the weight of this bucket, while this upthrust is the force from the water. Now, from equilibrium, we know that upward force will be equal to downward force. So that the upward force, tension. So tension here plus upthrust here is equal to weight. Of course, we said that upward force will be equal to what? Downward force. So from here now, make upthrust of the formula. Upthrust here will be equal to weight minus tension. This is our first formula for upthrust. But what's upthrust? Upthrust is called loss in weight, which is given as weight minus what? Tension. Of course, weight is Newton, tension is Newton. Both of them are force. So that loss in weight is what we call upthrust. Everybody, what's upthrust? Loss in weight. Now let's label what we gave. We said that weight is the weight of the body which is acting downward. Talk about the upthrust, right? Which is the force from the fluid, which is, look at it, it is the force exerted by the water, the fluid. It's called the upthrust, which is acting what? Upward. And tension, it is the pull on the ball or that rope on the bucket. That pull you are putting on the ball or that rope on the bucket is called the what? Tension. It is called apparent weight. What do you call? Apparent weight. So upward force for equilibrium, upward force is equal to downward force. Therefore, we now say that tension plus upthrust is equal to weight. So what now be called upthrust? Upthrust will now be equal to what? Weight minus tension. That loss in weight is what we call your what? Upthrust. Everybody, what's upthrust? Loss in weight. Lost in weight. Lost in weight. Loss in weights is what we call what? Upthrust. Are we good? Everybody, do you understand what is upthrust? Upthrust is what? Loss in weight. Now let's explain this thing mentally. Let's go deep. We already explained that upthrust is what is that upward force that make an object to become lighter when immersed in what? In fluid. Now look at it. Upthrust is an upward force exerted by a fluid. We already explained that force is coming from the fluid, not from the body. The upthrust is the upward force exerted by a fluid. When that body is partially or completely immersed in water, that body can be that bucket, that body can be that ball. That force from the fluid, that force exerted on the fluid, when that body is completely or partially immersed in water, is what we call your what? Upthrust. Now, why is this so? What causes upthrust? Look at it. Let me explain this. This is a bucket of water. There is pressure at the surface. Let's say this is pressure 1, and there's pressure at the bottom. Let's say this is pressure 2. Now, as you are forcing that ball inside the water, the pressure at the surface is the pressure at the bottom is greater than the pressure at the surface. As you are going down, the water too is pushing you up. As you are pushing it down, the water is pushing you up. That's what we call pressure. So that change in pressure, what will now be that change in pressure? That change in pressure will now be pressure P2 minus pressure 1, because pressure at the bottom is higher the pressure as at the top. As you are going down, the pressure increases. So that difference in pressure is what we call your what? Upthrust. So look at it. We say that pressure in a fluid increases with depth. Pressure in a fluid increases what? With depth. The pressure at the bottom of an immense body is greater than the one at the top. The pressure at the bottom is greater than the one at the top. That difference now in what is at the bottom and what's at the top, and the difference in the pressure at the bottom and the pressure at the top is what results to what we call your what? Upthrust. Look at this. The pressure difference produces a net upward force called what? Upthrust. So do you understand what causes upthrust now? That difference in pressure between the bottom and the top. Everybody, what is pressure? Pressure is the upward force exerted on a fluid caused by what? A body that is totally or partially immersed in water. Do you understand? Now let's now discuss Archimedes principle. Very trickish principle. Many of you know this principle, but you don't know the meaning. You just keep saying Archimedes principle is that when the body is wholly or partially immersed in fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. Now let's get Archimedes principle. Archimedes, come. Archimedes, we need you now. Come here. Archimedes principle states that when a body is wholly means total. When the body is totally or partially immersed in fluid, it experiences an upthrust. That force. But this is where it gets tricky. It experiences an upthrust which is equal to the weight of the fluid displaced by the body, which is equal to the weight of the fluid displaced by the body, which is equal to the weight of the fluid displaced by the body, which is equal to the weight of the fluid displaced by the body. Some of you may not understand this. Let me explain that. Let's say this is a bucket of water. This water is filled to the brim. I put a metal, a heavy metal, like this part. Let's say there's an opening here. Let's say like a funnel. If I forced this bucket, this metal inside here, some water is going to pour out. That upthrust, which is the upward force, is equal to the weight of the fluid displaced. That means this upthrust is equal to this weight in this water. The weight of the fluid, the water that is going to throw away, let me use layman language, is equal to the water that is going to throw away in this new bucket. I take that again. It experiences an upthrust which is equal to the weight of the fluid displaced by the body. This body is going to displace some water. That weight of that water is the same as this upthrust. Upthrust is equal. The Archimedes principle says that when a body is totally or partially immersed in fluid, it experiences an upthrust which is equal to the weight of the fluid displaced, which is equal to the weight of the fluid displaced, which is equal to the weight of the fluid displaced. You need to catch it in your brain. Catch it, that boy, catch it, that girl, catch it. Because we're going to use that concept to answer a lot of questions. Now, I know you say, oh, Sammy, why are you boiling? You know why I'm boiling. Let's get diagram. Now, all eyes on the diagram. We have that a body has a mass of 5 kilograms. How do we know it has a mass of 5 kilograms? You can see this is a beam balance. Everybody, what does beam balance? If you follow my class, beam balance measure mass, while spring balance measure weight. So this is a beam balance. So the mass is 5 kilograms. Of course, if the mass is 5 kilograms, me and you know that weight is equal to mg. So if the mass is 5 kilograms, what will be the weight? The weight will now be equal to the weight will be equal to 5 times 10, which is 15 Newton. So the actual weight of this body is 15 Newton. The body is heavier, it's still 15 Newton. It's coming down. When we put it in water, what do you see happen? When we put it in water, some part of this fluid was thrown away. And this weight is now appearing lighter. How do I know? Look at the beam balance that has moved to what? To 3 kilograms. That means the weight at this point is 13 Newton. So this is the tension now. This is the weight. So what amount of water was displaced? The mass of water that was displaced is 2 kilograms. If you convert this 2 kilograms, it's going to give us 20 Newton. Guess what? This 20 Newton is the upthrust. Why? Because Archimedes principle states that when a body is partially or totally immersed in fluid, it experiences an upthrust which is equal to the weight of the fluid displaced. What was displaced? This is 2 kilograms. 2 kilograms was displaced, and 2 kilograms in weight is 20 Newton. How do I know I'm correct? Look at it, everybody. This is the tension. This is the weight. Of course, the tension now is reading. What's the tension reading now? When it is inside water, the tension is reading 13 Newton. what is coming out? What is coming out is what is coming out here is 20 Newton. That means the upthrust is 20 Newton. If you put two of them together, what is it going to give us? It's going to give us the weight. We know that we're going to give us the weight, which is what? Weight here now will now be equal to what? 50 Newton. And that agrees to the formula. What does the formula says? It says that your tension plus your upthrust is equal to weight. We will now say that upthrust is equal to weight minus tension. Do you remember this formula? We derived it just now. So Archimedes' principle is saying that that amount of water that is going to come out when a force is exerted on that fluid, that amount of water that is going to displace is equal to the upthrust. You have balanced it. Here is 30. Here is 20. Of course, if you total 30 and 20, you're going to get 50, which is the actual weight. So the reason why that object is appearing lighter because the amount of water that has been displaced is that upthrust. And that upthrust is the force that is not acting on it to make it what? Lighter. Am I speaking to somebody? Say, talk to me, Saemi. If you are feeling it, clock it, clock it. Everybody type clock it in the chat. Clock it, clock it. Or come to my DM and say, clock it. Are you catching it? Catch fire. Anybody what does Archimedes' principle state? It states that when an object is partially or totally immersed in liquid, it experiences an upthrust, and that upthrust is equal to the weight of the fluid displaced. It's equal to the weight of the fluid displaced. So upthrust, this is where we're going to solve the past question. So keep this in mind that upthrust is equal to weight of liquid displaced. So they can ask you, calculate the upthrust if the mass is 20 kilogram. You don't need to solve here. Upthrust will now be equal to, upthrust is equal to weight of displaced. So weight is equal to mg. So upthrust will now be equal to 20 times 10, which is what? 200 Newton. Are you seeing that? Because actually, tell them who said that Archimedes' principle. Don't say that when an object is totally fractionally immersed in fluid, it experiences an upthrust which is equal to the weight of the fluid what displaced. Let's run out of here. Now, please, from here now, there's a constant formula. That formula you still see it in front. Let me prove it to you. Take note that mathematically, we can express that upthrust. This is the second formula for upthrust. Upthrust, what was the first formula I gave for upthrust? Say that upthrust is equal to weight minus tension. Upthrust is equal to weight minus tension. Another formula for upthrust is that upthrust is equal to density times volume times g. Now, this is density of the fluid. This is the volume of the object, while this is gravity. So, where that's density of the fluid, while v is the density of, either you say density of the object or you say density of the displaced fluid. Okay, let's use density of the displaced fluid. Density of the what? Of the displaced fluid, because upthrust is equal to density of displaced fluid, where g is what? Is gravity. Please, so we have given two first formula for upthrust. Upthrust is equal to w minus t. One. Second formula for upthrust. Upthrust is equal to density times the volume times g. Now, another thing we also need to talk about is that take note that when a body is completely immersed, look at it. A body completely immersed displaces a volume of liquid equals to its volume. Now, let me explain this. Let's say, for example, this is it. This is a bucket of water. This is a stone. Of course, Archimedes says water will be displaced. Now, the volume of this stone is equal to the volume of this water displaced. That's what I'm saying. A body completely immersed in water has a volume equal to the volume or equals to the liquid. Look at it. A body completely immersed displaces a volume of liquid equals to its own volume. So the liquid here volume is equal to its volume. So if the body is partially immersed, that means the volume here, that means this volume here will be equal to half of this volume. If it is 1/3, depending on what it on how it is. Look at it. Let's say this one is immersed. It's immersed like this. It's small part. Let's say this part is 1/3. So the volume now will be 1/3 of the total volume. That means the volume that is in this water now, the volume that is in this container, this water here will be 1/3 of this. So it responds to, if this is totally, that means this volume here will be total volume of this. If yes, one is half, the volume here will be half of this volume. Look at it. A body partially immersed in water displaces only the fraction of its own volume. That's why I explained to you that if here the total volume, if the body is totally immersed, that means here will be the total volume. If here it is half immersed, I mean this volume will be half of this volume. If it is 1/4, it is 1/3 of that volume. If it is anything, it is that fraction of that volume. Therefore, if it is one fraction, we say that it is fraction of that volume immersed times the density times g. This is g. We are still following that formula, but this volume here, we say it is fraction. So if it is 1, it is now 1/2 of the total volume, or 1/3 of that total volume, depending on what the question is. You see that in what? Do you understand? Now, take note that what is upthrust? Upthrust is loss in weight. So on that formula, the third formula for upthrust, we are going to know that upthrust is given as weight in air minus weight in liquid. Look at it. When the body is immersed in fluid, the upthrust now become weight in air minus, look at it, upthrust will become to weight in air minus weight in liquid. This is the third formula. We have given 3 formula. What is the formula? Formula that says that upthrust is equal to weight minus tension. Second formula from upthrust is equal to density V. So this is the third word formula. Do you understand? Quickly, if you say you understand that, let's now talk about the volume immersed. The volume immersed has a very funny formula, which we are going to see as we move. That volume immersed states that the volume of the fraction immersed is given as, please let me write it there, is given as the volume immersed all over the total volume is equal to density of the object all over density of the fluid. Now, this formula will look tricky, but we're going to see it as we move forward. Look at it. For floating objects, volume immersed all over the total volume is equal to density of a body all over density of fluid. Please keep this formula. It may look somehow, this is the fourth formula. It may look big, but we're going to see past question on that. Do you understand? So quickly now, let's summarize all the formulas we gave in this part. Number 1 formula, we gave that upthrust is equal to density times volume times G. We also gave that upthrust is equal to air minus what? Liquid. We also gave the formula that density is equal to volume immersed all over total volume is equal to density of the body over density of fluid. We say we are going to use number 3 very well as we move. And the fourth one, don't forget that we said that upthrust is equal to weight minus tension. Therefore, from here now we can say that tension is equal to weight minus what? Upthrust. So it's still the same thing. So these are the first 4 formula. Calm down and understand it. Go through it, because guess what? We are moving to past question. And that's where I will catch you. This is part 1. Inside part 1, we are just seeing upthrust. We are going to discuss the past question. I'll see you in that class. But for now, just go and rest first. We'll treat past question in the next class. But for now, peace out.